We propose COCOI, the deep RL method that uses history robot-object interaction samples to infer contact dynamics context. We study COCOI on a novel and challenging non-planar pushing task, where the robot pushes an object to a red goal location while keeping it upright. In Q-learning, baseline Q function takes current state and action and directly maps them to the predicted Q value. We propose to append another string that takes in history samples and predict the representation of the system dynamics context. We also propose a contact-aware history sampling method. In contrast to the vanilla sampling method that uniformly samples history sensor messages, we only take samples when the force magnitude is considerably large, that is, when the robot and object are in contact. We test our methods using 75 objects and separate them into a training set and a testing set. While the baseline can push the objects over, our method is capable of pushing the object to the goal location while avoiding pushing it over. We report that our policy achieves the following smart behaviors. The robot can actively break the contact with the object and adjust the pushing direction. The robot can also break the contact with the object in order to avoid pushing the object over. COCOI works robustly on various objects and different dynamic settings. For example, pushing a heavy object with large friction, which is easy to tilt and fall. And for a light object with small friction, which is slippery. COCOI can also handle challenging objects. For example, pushing a goblet that has very irregular shape and whose center of mass is relatively high. And a stack of cups where the upper cup can move inside the lower cup, making the center of mass shaky. Overall, we show consistent better performance of COCOI compared to the baselines. We also deploy our method to the real-world robot. The policy trained using simulation images cannot adapt to the real world. We train a GAN adapter to adapt the simulation images to be very similar to the real-world images. And we validated the method can overcome the sim-to-real gap and succeed in real world in a zero-shot manner.